The shift register is another type of sequential logic circuit that can be used for the storage or the transfer of data in the form of binary numbers. There are 5 types of registers. SISO mean serial in, serial out. Second, SIPO, serial in, parallel out. PISO, parallel in, serial out. And PIPO, parallel in, parallel out. And the last one is universal shift register. Okay. Serial in, parallel out. The register is loaded, with the serial data, 1 bit at a time. When the stored data being available, where the stored data being available at the output in the parallel form, then it is called serial in, parallel out. Okay. Serial in and serial out. The data is shifted serially in and out of the register, 1 bit at a time, in either a left or the right direction under the clock control set. Now then, third type is parallel in, serial out. The parallel data is loaded into the register simultaneously and is shifted out of the register serially, 1 bit at a time, under the control of clock. Last one is parallel in and parallel out. the parallel data is loaded simultaneously into the register and transferred together to their respective outputs by the same clock pulse. Okay, fine. We are going to discuss 4-bit serial in parallel out shift register. 4-bit mean we are using 4 flip-flop D flip-flop 4 flip-flop E, B, C and D. Okay. Now data will be inserted here. Okay, to this end. And this is our data. 0 and then 1, then again 0. And output of the first flip-flop A is given to the input of the second, and output of the B flip-flop is given to the input of the C flip-flop. Output of the C flip-flop, that at here, is given to the input of the D flip-flop. Okay, output of the A flip-flop is QA, and output of B flip-flop is QB. Then output of the C flip-flop is QC. Output of the D flip-flop is QD. A clear pulse can be activated, and it is given to all the flip-flops. And a clock pulse is given to all the flip-flops simultaneously. So this is the line for the clock, So this is a clock, high and low and high. First pulse, second pulse, third, fourth, fifth, 5 clock pulses. Okay, now let's we discuss the working of the 4-bit serial in and parallel out shift register. Okay. Now what happens? Let's that before the data is applied, okay, the clear is activated so that output of all the flip-flops QA, QB, QC, QD are in the lower positions, that QA 0, QB 0, QC 0, QD 0, and clock is also disabled at that stage at that time. So clock is disabled, output QA, QB, QC, QD, all are zeros. Now then what? Let 1-bit data comes here at this end. When 1-bit data comes here, and then let the clock pulse is activated. Okay, clocks go high like this. Clock go high. The first clock pulse. Now the clock go high here to all the flip-flops. So what will happen? The data at here will be transferred to here. And what was the data here? That, at the 1 was here, it is shifted this place. And at that time previously 0 was here, that is shifted here. So 0 was here, that is shifted here. 0 was here, that is shifted here. So this output becomes 1, 0, 0, 0. So 1, 0, 0, 0. 1, QA is 1, then 0, then QB, QB at that time when it is 1, QB is equals to 0, QC 0, QD 0. Now let next second clock pulse enters. Second clock pulse, it triggers. The rising edge of the second pulse appears. So what will happen now? Already one was here, So what will happen? One was here, it will be shifted to this place. Now after one bit there is a 0. So 0 will come here, 1 will come here. Previously it was 0 here, so 0 is shifted to this point and that 0 shifted to this point. So this becomes 0. Here it is transferred 1, then 0, then again here 0. So second, the result is 0, 1, 0 and 0. So this is the, diagram. The second, the QP, it is showing high level 1 at the second clock pulse. When the second clock pulse triggers, then output of QB is high. So similarly, when the third clock pulse, the rising edge of the third clock pulse, it enters. So already one was here. Then it will be shifted to this place. Okay. So 0 will be shifted here. So this 0 will be shifted here. So 1 is here and previously it was 0. That will be shifted here. So now only the QC, it will show high and all others are 0. Okay, only the QC is high, all other are 0. Now similarly, when the fourth rising edge of the clock enters, so what will happen? So already one was here, it will be shifted to D. 0 will be shifted to here. This 0 will be shifted to here. This 0 will be shifted to here. Now only the QD will be high, all others are 0. QD is equals to high, all other are 0. So if when the fifth enters, all becomes 0 because the one was here, it will be then shifted to the next system. And then QA, QB, QC, QD all becomes 0. So this is the working of 4-bit serial in, parallel out. Okay. Now conclusion is the effect of each clock pulse is to shift the data content of each stage one place to the right, and this is shown in the table below until the complete data value 0001 at the end of the fourth pulse is stored in the register. This data value can now be read directly from the output QA to QD. So this is the action of very simple, only just the shifting the data when the clock arrives. What of the data here shifted this place with clock. When again clock arrives, this data shifted here. When again clock arrives, so this process continues. So this is the working. Okay. Now we discuss about serial in, serial out. Serial in, serial out. Through register, serial in data and serial out data. This register is made up of 4 flip-flops. FF0, 0 is first, okay? FF0, FF1, FF2 and FF3. The output of the first flip-flop is the input of the second and so on. And we are using only the D flip-flops. A clock pulse is applied here and it is activated simultaneously to all the flip-flops. Okay. Now looking here, this is a table that initially Q0, Q1, Q2, Q3. There is no clock pulse initially. Output of Q0, Q1, Q2, Q3 all are zeros. 0 here, 0 here, 0 here, 0 here. Now let the data arrives here. Data is 1 and continues 1. It arrives here. And this is a clock pulse. And let the clock pulse arrives. First clock pulse arrives at here. What will happen? The one at here will be shifted to this place with first clock pulse. And 0 was here, already shifted to here. This 0 here, this 0 here. So after first clock pulse, Q1, Q0 will be first clock pulse, Q0, output of Q0 is 1 and all others are 0. Second, third, first, second, third, output 0. This is after first clock pulse. Now when the second enters, what will happen? This one at here will be shifted to this place. That is, this one here will be shifted to this place. And 1 here arrives to this point. So output of first is Q0 is also 1. 1 was here shifted to this place. So Q1 is also 1. Flip-flop 1 output. Q1, this one is also 1. This is 0, this is 0. So this is 0, this is 0. Okay. Now then, when the third clock pulse arrives, this one, third arrives, what will happen? The one at here will be shifted to this place. One at here shifted to this place. One at here will now come this point. 0 was here, shifted to here. So third clock pulse, what will happen? This one will be shifted here. This one will be shifted here. This will be shifted here. Okay. And Q last one, here it is 0. Now 1, 1, 1. 1 is here, 1 is here, 1 is here. And here it is equals to 0. Now again when the next clock pulse arrives, fourth one, then this one will be shifted here, this one to this place, this one to this place, this one to this place. So okay, last one, Q4, 1, 1, 1, 1. This shifted here, this one here, this one here, this to this, this to this, this to this, like that. Now at this moment, all outputs are 1, 1, 1, 1. So this is how the data is serially it is shifted, this end to that end, and shown by the timing diagrams. How one arrives at here for Q4. Q4 arrives when the fourth clock pulse comes. So this is last one. This is fourth, but we are calling it Q3. This fourth one we are calling it Q3. This is third one, we are calling it Q2. Okay, Q2 is like 0, 0, 0, 3 zeros and 2, 1, 1, 1. Q1, 2 zeros like and 3, 1 like this. Q0, 1, 0 and 4 ones with the clock pulses. So with the clock pulses. Okay. This is a circuit diagram for parallel in, and serial out shift register. Okay. Here, like a system, this system like this, to AND gates and OR gate, one NOT gate, to AND one or one NOT, to AND one or one NOT, connected to each flip-flop, each D flip-flop, and a clock pulse can be given simultaneously to all the flip-flops. Okay, data can be entered at this point, at this point, at this point, at this point, simultaneously. D1, D2, D3, D4 data can be entered simultaneously only when this line will be at low. Then data, whatever the data here, it will shifted this place, this place, this place and this place only when this line will be at low. Then by activating the clock, the shut data is that data which appears at here, at here, at here and at here. It is shifted in downward directions when the clock pulse arrives. Okay. Let's see how. Let the data is, data is 1, 1, 0, 1. It arrives. The data arrives 1, 1, 0, 1. Okay. And let's we assume that serial in mode is off. That serial in mode is disabled at that time. So it is 0 here. And because this line is at low, then because of NOT gate it becomes 1. Because of NOT it becomes 1. Because of NOT it becomes 1. It becomes 1. So, previously let we suppose 0, 0, 0 was here. Okay, previously let 0, 0, 0, 0. So this 0 comes here and like that. So it is 1 here, 1, 1 is 1 AND gate. And if 0 is at one line, then AND gate will give the 0 because 0 is here. Whatever the other, the output is 0. 0, 1 OR gates give 1. This is 1 and data is 1, 1, 1 AND is 1. And whatever this, no problem. This is 0 actually. Then 0, 0 is 0 is here, 1, 0 is 1. Then D3 data is 0. And 0, 1 is 0. And this line is also 0. So 0, 0 is 0. Then this is 1, 1, 1 mean 1, and 0, 0 means 0, 1, 0 is 1. So all the data 1, 1, 0, 1 arrives at here 1, 1, 0, 1. Okay, and then that by when the clock pulse now activated, the data will shifted from here to here, this place to this place, this one to here, this one to here. So data is shifted, So whatever the data presents at the input will be shifted to the just input of all the flip-flops when the shift load line is activated, mean when it is at low. But remember, this is low only for just short while. Otherwise it is high. So for short while it is low and data is then shifted. Now let's the clock pulse is activated. When the clock pulse is activated, the data at here will be transferred at the output of the flip-flops. Whatever the data at the input will be transferred to the output when the clock is activated. Okay. So data is here 1101 which was present here. It is now at the output of the register 1101. Now then how this data is, it is transmitted serially in the outward direction. It is with the help of the clock now. With each clock pulse, the data will be shifted from here to here, here to here, and here to here. Okay, like in this direction with the help of the clock pulse. Right? Hello my dear friends, please subscribe my channel and do not forget to click on a bell icon to get the notifications about my new work. Thank you very much.